So as you can see, this lesson is about equations of lines. All right, so let's get started. On this first one, it says to find the slope and y-intercept, then graph the linear equation. So we're going to put this in slope-intercept form, which hopefully you recall that that is going to be in y equals mx plus b form. So we're going to solve for y by subtracting the 3x. And then divide each term by -1. So y is 3x plus 1. All right, so notice that I'm dividing by a negative, so that switches the signs of everything I was dividing. Now, I identify my slope, so my slope is 3, and my y-intercept is 0, 1. Now for graphing purposes, I would want to write the slope as a rise over run, which would be 3 over 1. And then I can put that on the graph and count to graph this line. So this is a really great and easy way to graph. I start with the y-intercept, and remember that is on the y-axis. And then from here I count up 3, 1, right, 1, 2, 3, and right 1. Right, my rise is 3, so up 3. My run is 1, so right 1 because it's positive, and then draw the line. Now, you can put more points on this line if you want to than this, because from each point you graph, you can count your slope again. So, I just kind of missed there completely. So I could count again if I wanted to, right? From this, I could count 1, 2, 3, and over 1, right? There would be another point, 1, 2, 3, right 1, and there would be some more points on this line. It gets harder to hit the more points you put. So maybe you want to just leave it at 2. All right. Next, same thing. We're going to solve this equation for y. So I'm going to subtract 2x on both sides. So 4y equals -2x minus 16. And then I'm going to divide by 4 on each term. -2/4 is the same as -1/2. And then minus 4. So now I have a slope of -1/2. Generally, we think of the negative with the numerator when we're counting on the graph, and that's what I'm going to do. And then I have my y-intercept at 0, -4, and it is the y-intercept. Don't forget that part. So on the y-axis, I put a point at -4, right? 0, -4 is that point. And then from that, I'm going to count, right, because it's -1/2 on my slope. This is down, and this is right. Right, down 1 because it's negative, right 2. Down 1, right 2. Now I could put the negative on the opposite way, right? So then I'd have a 1 over -2. So it would be 1 up, and it would be left 2. So let's look what happens. If I go up 1 and left 2, notice I'm still on that same line. Sometimes this is handy if you're at the top or bottom of the graph and you're running out of space or something, then you could switch the signs just so you could go in a different direction. Then of course we're going to draw the line. Okay, that's not too bad. I'm just going to leave it there. You do not have to put 4 points on your line. I just like to show that so you can understand that if you need some more on there, go ahead. It's perfectly fine. Okay, so now we're going to use slope-intercept in a different way to write the equation of a line. And this just means that you have to understand what you need. What do I need to write the equation of a line? Well, if I have a slope and I have an intercept, then I can write that equation. Because remember, I have this y equals mx plus b. So I have the m and I have the b, and therefore I can write the equation. So I'm going to say y equals negative 3x minus 1/5. So I've just written the equation of a line. If you're given the slope and the intercept, you really don't have to do any work. You just have to know, hey, I've got everything I need for this equation. Okay, on the next one, we're going to do the same thing. All right, so we're going to use this slope-intercept form of a line. My slope is my m, and this, right, the y coordinate of my ordered pair is my intercept, and that's where it goes through the y-axis. Well, we don't put zeros in our equations, right? So we're simply going to say y equals negative 4/5 x, and that's it. We don't write the zero in this case because it's not necessary to have the zero in your equation. Okay, so this is writing equations when we're given the slope and the y-intercept. What happens if we're not given the slope and the y-intercept? Well, we can do something called point-slope form. So with point-slope, I simply have to have a point and a slope, right? So we need a point, we need a slope, and with that we use this formula, so it's y minus y sub 1. That means I'm going to take y and subtract the y coordinate of the ordered pair. Here goes my slope, and then I'm going to take x and subtract the x coordinate of the ordered pair, and the parentheses are necessary, they must be there. And this is called point slope, right? Point slope form of an equation. Now, you're also going to be told to put your equations in certain forms once you have used the formula. Okay, so this is like a formula. Find the equation of the line with the given slope and containing the given point. Write the equation in slope-intercept form. Okay, so first, let's write out this equation or this form. It's a formula, right? So point slope form is y minus y sub 1 equals m parentheses x minus x sub 1. If you leave off the parenthesis, your equation won't be right. Okay. Now I'm going to substitute, and this is nice because they're both positive numbers. So this is my x sub 1, here's my y sub 1, and this is my slope. So I will have y minus 1 equals 4 times x minus 5. And then I will simplify and write this in slope-intercept form. And that means I distribute. So distributive property, that makes a 4x minus 20, right? Because I multiply the 4 times both terms in the parentheses. Then I'm going to add the 1. So my equation is 4x minus 19. So in this case, I have a slope of 4, which you knew from the beginning, but you didn't know the intercept. So this is a way to find the y-intercept, and it's at negative 19. Now, there are other ways to write the equation of a line. You can use slope-intercept, y equals mx plus b, in another way. And so I'm going to show you that on this first question, but mostly I'm going to use point slope. Okay, so let me just do this. If I were going to work this one out with slope-intercept, then I would take this equation and substitute for the x, for the y, and for the m, and find the b. Okay, so that means for the y, I would put in 1, 4 goes in for the slope, the x-coordinate is 5. And I have to have the b here in order to do this method. So now I have 20 plus b. I'm solving for b, so I subtract 20 on both sides. And I find that b is negative 19. I already knew my slope was 4, so you can see that either way we get the same equation. And these are two different methods. I honestly don't mind you using either method. I do feel that if you struggle with this a little bit, then you might do better with point slope. Okay? And that's actually the one I'm going to show the most. Okay, so we're going to use that same point slope formula. I'll write it out here. This time we're going to write our equation in standard form. Okay, so we're going to work through this and substitute. This is for my x sub 1, that's my y sub 1, here is my m, my slope. So if I take y and subtract 4, right, y minus 4 equals 2/3 times x. Now this is minus negative 9, and it's really messy if you put a double negative when you're writing an equation. Oftentimes students get messed up when they do that. So let's just go ahead and make that a plus. And then we distribute the 2/3, so that's 2/3 x plus 2/3 of 9 is 6, right? If 3 goes into 9, 3 times 2 times 3 is 6. There, you can always use your calculator if you didn't follow that. We add 4, and we find that our equation is 2/3 x plus 10. Now, this is in slope-intercept form, and I need it in standard form. Remember, standard form is ax plus by equals c, and we don't leave fractions in the equation when it's in standard form. So let me take this up here. All right, so I'm going to subtract the 2/3 x and put it and write it on the other side of the y. So negative 2/3 x plus y equals 10. Okay, so I'm going to do two things here. I'm going to get rid of the fraction and the negative on the x. Okay, I can do this by multiplying by negative 3 on both sides of my equation. So if I take negative 3 times negative 2/3, that will give me just a simple 2x. Negative 3 times y is negative 3y. 10 times negative 3 would be negative 30. And then that's it. It's in standard form. Now these two equations mean the same thing. They're just in a different form. All right. So I'm going to stop this video and finish this lesson, starting up with the next video.